All right, back to day 29, our balancing. Let's talk about balancing chemical reactions. So you have your 5 classes: your combination or synthesis, your decomposition, single replacement, double replacement, neutralization. So now let's talk about the stoichiometry, right? So this chemical equation represents a chemical reaction. So the chemical equation represents the chemical reaction. It's a rearrangement of the same sets of atoms. Bonds are broken and new bonds are formed. All right. Now, the coefficients. This is important. The coefficients describe the stoichiometry, the moles of reactants required, and the moles of products formed. All right. And this equation must be balanced. Okay. And we can't change the identities, but we need the same number of atoms on both sides. All right. We can't change the identity of the compounds. We can change, right, the ratios. So if you look, this 2 is in front of aluminum to represent 2 overall aluminums. This 3 is in front of bromine to represent 6 bromines. All right. Now, unfortunately, for some of us, we would like to just make this, right, put a 2 down there in aluminum, and I make a 6 there, and it works out, but it doesn't work that way. Okay. We can't change the subscripts. Changing the subscripts changes the identity of the compound. Can't do that. So balancing equations. I'm going to recommend step 0 to you guys, which would be use pencil, because we may have to erase. All right. Then what we do is we select the most complicated formula and balance those atoms first. All right, so you got to use pencil. Correct formulas, that's important. The most complicated formula. Then those that only occur in one formula on each side, and finally leaving the simple molecules till the end. Why do we do that? Because if I put something in front of H2 here, or O2, it does not affect any other atom. So let's balance real quick. 4 aluminums, 1 aluminum. So I have to put a 4 there. 3 carbons, 1 carbon. Put a 3 there. Now what happened here? How many oxygen are on the right hand side of the equation? Well, there's 3 times 4 is 12. So I need to put a 12 there. How many hydrogens are there? 4 times 3 is 12, plus 3 times 4 is 12. It's balanced. Ammonia, NH3. All right, so if we look, 1 nitrogen, good. 3 hydrogens, 2 hydrogens. All right, well, 3 and 2. That doesn't work out so well, does it? So we need to put a 2 here and a 3 in front of the water. So now we have 6 and 6. But that changed nitrogen. So I need to put a 2 in front of nitrogen. All right, so now how many oxygen do we have on the right-hand side? 2 plus 3 is 5. Ooh, right? So what happens here when you have an odd number of oxygens? A lot of times we're going to double a lot. All right, we're going to have to double. So put a 5 there. I have to put a 4. I have to put a 2 and a 6. All right, same with All right, so that's just what's going to happen. 3, 8, 2, 4, 8, 8 and 8 hydrogens. 4 and 6 is 10, 5. So when we do these stoichiometric calculations, we work in moles. 1 mole of propane requires 5 moles of oxygen. 1 mole of propane produces 3 moles of CO2.